Good afternoon, class. I am by name Umaru Sani. I'm here now to take a course MTH111. So my own part to handle is indices and logarithm. And if we are done with that indices and logarithm, we extend to complex numbers. So we start with the indices. So in mathematics context, a short form of written number says to be a times a times a is a to the power of 3. So the letter a is called the base, while the number 3 is the power or index or exponent. So we go by the law of indices. The following are the law of indices and the fact about them. 1. A raised to the power of n times a raised to the power of n to be equal to a raised to the power of n plus n. This means if you are multiplying a number with the same base, you add the power. So number 2, if a raised to the power of n dividing a raised to the power of n, the result is a raised to the power of n minus n, meaning if the number of the same base divided, then you will minus the power. 3. A raised to the power of n open and close n equal to a raised to the power of mn. Meaning here now, if you now multiply it as in a raised to the power of n open and close, the power m now multiplying the one outside, that is the n outside. When you open the bracket, the power now will multiply themselves to give a raised to the power of mn. Then 4, a raised to the power of 0 divided a raised to the power of n equal to a raised to the power of 0 minus n, and that extends to equal to a raised to the power of minus n. So if a number is raised to the power of n as a minus n, then the result now will be 1 all over a raised to the power of n. So it is because of the word the minus power of that particular number that is said to be what? 1, then divided by a to the power of that n. Then 5. A raised to the power of n divided a raised to the power of n. That is the same base dividing the one with the same power. So as we are dividing the power of it, now you got you minus. So a raised to the power of m minus n will be equal to a raised to the power of 0. And anything raised to the power of 0 is 1. Number 3, as in number 6, a raised to the power of 1 over 2. So because of 1 over 2 can be written as as the a raised to the power of 1 all over n equal to n the square root of a. So where n can be any number, then 7 a raised to the power of m all over n. This can be transformed to the square root of a all to the power of m. So with these 7 loops, you will have them in the back of your mind to worry about an example is given for you to solve or to simplify any given an indices. Then you recall all those loops to the nature of the examples given, then you will use them and apply to get your result. Now, the loss and the fat above now will be implied in the following examples. Simplifying the following. 1. 5 raised to the power of 2 times 5 raised to the power of 4. 2. 3 raised to the power of 9 divided 3 raised to the power of 4. 3. 5 raised to the power of 2 open and close to the power of 2. 4. A raised to the power of 2 divided a raised to the power of 2. 5. 6 raised to the power of minus 3. Now the solution, we take them one after the other. So if we recall with the loads, then we go by this. As 5 raised to the power of 2 multiply 5 raised to the power of 4 equals to 5 raised to the power of 2 plus 4. Meaning, as you are multiplying the same base, you will now what? Add the power, as you can see. Then the result now will be equal to 5 raised to the power of 7. Now number 2, 3 raised to the power of 9 divided 3 raised to the power of 4. As you are dividing, having the same base, you minus the word the power. So we now have 3 raised to the power of 9 minus 4. And that gives us 3 raised to the power of 5. So if you don't go by that way as they are dividing, 3 raised to the power of 9, it means 3 times 3 times 3 times 3 up to 9 divided 3 raised to the power of 4, it means 3 times 3 times 3 up to 4 times. Then 3 can cancel 3, 3 cancel 3, now we will be left with what? 3 and to the power of what? 5. Then number 3, 5 raised to the power of 2 open and close to the power of 2. As when you are to open the brackets, the power now will multiply. Then we have it as 5 raised to the power of 2 times 2. And that will give us 5 raised to the power of 4. Number 4, a raised to the power of 3 divided a raised to the power of 3. As you are dividing, you minus the power. So 3 minus 3 as the power equals to a raised to the power of 0, and any raised to the power of 0 is what? Is 1. So number 5, 6 raised to the power of minus 3. So once any number is raised to the power of minus, mathematically we can transform into 1 all over that particular number to the power without the minus. As you can see, 6 now raised to the power of 3. So meaning 1 all over 6 raised to the power of 3. And 6 raised to the power of 3 can be transformed to what? 6 times 6 times 6, 3 times. And the result now will be 1 all over 216. So we have that. Then when we go further, we still have some examples that have in different in nature compared to the one we have done. Let's take for instance. Consider the following. Giving A now said to be 6 raised to the power of 2 times 3 raised to the power of 0 times 6 raised to the power of minus 3, all divided by 5 raised to the power of 3 divided by 5 raised to the power of 6. Then B, the square root of 2 whole number 7 all over 9. C, 64 raised to the power of 1 all over 3. And D, 216 raised to the power of 2 all over 3 divided by 81 raised to the power of 3 all over 4. So when you look at these particular examples, it's quite different from the one we have done. So when you go by the same ideology coupled with the load you have, then you'll be able to simplify to get your result. Now let's take this. Picking A, 6 raised to the power of 2 times 3 raised to the power of 0 times 6 raised to the power of minus 3, all divided by 5 raised to the power of 3 divided by 5 raised to the power of 6. So as the laws tell us from the beginning, when you are now multiplying what have the same base, you plus the power. Is that clear? Now when you look onto this, we have 6 raised to the power of 2, and then we have this one now 3 raised to the power of 0. That one 3 raised to the power of 0 can give us 1. Then we have the one with the same base, 6 to the power of 2 and 6 to the power of minus what? 3. Now in this case, since the base is the same, you plus the power. So we can now transform that now to 6 to the power of 2 plus, open bracket, the minus 3 times 1. Because already the one with the power of 0 is 1. So divided by, you can write this one down. 5 raised to the power of 3 minus, as in divided 5 raised to the power of 6. So at this point now we transform this to, when we multiply the base, so 1 times this is giving us 1. So when we open this bracket now, 2 plus open bracket minus 3 close brackets. By opening the bracket now, we will left with what? 6 raised to the power of minus 1. Because 2 minus 3 now will give us minus 1. As we are now dividing the base that having the same as in the number having the same base in our word minus the power, as you can see. So 5 now is going to be what? 3 minus the 6. At the end now we also have the result 5 raised to the power of minus 3. So at this case, when we further simplifying, we can transform this 6 raised to the power of minus 1 to as 1 all over 6 raised to the power of 1 divided 5 as a 1 all over 5 raised to the power of 3. So when you are dividing this number, at the end now we have this result. 2 all over as 125 all over 6. Meaning 1 all over 6 to the power of 1 divided by 1 as a 5 raised to the power of minus 3. So as you can see now, when you change the base, as in when you change the division sign now to multiplication sign, then the first fraction will remain there. You interchange the position of the second fraction. The numerator will become denominator and denominator will become what? Numerator. So the numerator multiply numerator divided by the denominator divided what? Numerator. And we have this particular result, 125 all over 6. Then the B part. We have two whole numbers, 7 all over 9, all in what? In root. So in this point, we cannot transform this to 2 times 9 times 2, all over 9. So the 9 can cancel 9, we will be left with what? 2 times the 7. So 2 times 7 now will give us the square root of this. It means now we have the 25 all over 9. So we cannot transform this to be as the square root of 25 all over the square root of 9. So we can take the square root of 25 to give us 5 and the square root of 9 to give us 3. Then this will serve as the result of what we want. Then this example 3. 64 raised to the power of 1 all over 3. This can be transformed as 3 the square root of 64. So with this, seeing this 3 that is outside of the root, so you think of a number when you multiply it by himself 3 times, that is to the number of what is outside the root, that the result will give you that 64. Then that number now is the answer to that particular expression. Meaning when we now say it 4 times 4 times 4, 3 times will give us 64. So it means 498 is the answer. But when you press calculator directly, you say 3 the square root of 64, the result will be 4. But without the calculator now, you think of a number where you multiply it 3 times, the result will be this 64, then that particular number now is the answer. Then the number, that is the D part, 216 raised to the power of 2 all over 3 divided by 81 raised to the power of 3 divided by 4. So we can transform this 216 to the power of 2 all over 3 into 3 the square root of 216 all raised to the power of 2 divided by, also this one can be transformed to 4 the square root of 81 open and close all to the power of 3. So in this point, you also think of a number when you multiply it 3 times, that it will give us 216. And also to this one, you think of a number where you multiply it 4 times will give us what? 81. So to this 216, it means you will now say 6 times 6 times 6. 3 times will give us that number. Then 6 now is the result that will give you 216, and all you raise it to the power of 2. Also to this 81 now, what will be the number then is what? Is 3. 3 times 3 times 3 times 3, 4 times will give us 81. So it means that's 3 now raised to the power of 3. So as 3, as in 6 raised to the power of 2 divided 3 raised to the power of 3, this can be transformed to this. When you are dividing, this division sign now can be transformed to this. So as well, you raise the 6 to the power of 2, give us 36. You also raise 3 to the power of 3, give us what? The 27. So you look for a common factor. You reduce the fraction into what? The smallest fraction. And when you do that, then you have this. Is that clear? So in this point now, we can go further. Identical equations. So these are equations having the same unknown letters as a power or index or exponent. Take for instance, consider 2 raised to the power of x equals to 8. Note, write 8 as 2 power, that is 2 raised to the power of x equals to 2 raised to the power of what? 3. Equating the power, we have x equals to what? 2. In these situations, wherever an expression is given for you now to what? To simplify. So as 2 raised to the power of x equals to 8. So you think of what, as in the missing, the base of this one is 2 raised to the power of 3. Then you also think of 2 raised to what power, that it will give you exactly 8. So that should be, so that you have to make the base the same. If the base are the same, now you create the power. And that is what was done here now to what? We have this. X raised to the power of x equals to 2 raised to the power of 3. Then the base is the same. Equating the power now, we have x equals to what? 2. Also to this very one, 3 raised to the power of x equals to 81. So 3 will raise to what power? It will give you 81. So you think of that. You text it. You raise your t to the power of 1, give us 3. 3 to the power of 2, give us 9. 3 to the power of 3, you text like that now. It will take you to a certain number. It will give you the result 81. So you raise the 3 to the power of that number. As you can see here now, we raise the 3 to the power of 4. As the base is the same, you equate what? The power. And that's time to what we are looking for. So we also have another different examples. So let's take for example like this one, you are now to simplifying it. 4 raised to the power of x plus 1 equals to 2 raised to the power of x minus 1. Number 2, 8 raised to the power of x equals to 0.5. And number 3, 9 raised to the power of 2 minus, as a raised to the power of 2x minus 1 equal to 81 to the power of x minus 2, all divided 3 raised to the power of x. So going with the law, we can simplify this example as well. Now let's look up to it now. Let's take the number 1. So 4 raised to the power of x plus 1 equals to 2 raised to the power of x minus 1. So since the base of the right hand side is 2, so you also what? Think of the left hand side now, this very 4. You want to make the base the same, then you raise 2 to what power, which will give you what? 4. So at this point, you raise your 2 to the power of 2, it will give us 4. So we can transform this one to this. So 2 raised to the power of 2 into the power already existing x plus 1. Open and close. Then it's equal to 2 raised to the power of x minus 1. So since you make the base not the same, you what? You equate the power. So when you equate the power, open the bracket of this, the left hand side of this very equation. So 2 multiply x will give us 2x. 2 times 1 will give us 2. And that will be equal to the x minus 1. So when you rearrange, so 2x plus x minus 1. So 2x plus x that will give us what? 3x. Minus 1 plus 2. And that will give us what? 1. So in this case, we are looking for the x. So 3x now will be equal to 1. So when we divide both sides by, the result now will give us to 1 all over 3. Then the second example is 8 raised to the power of x equals to 0.5. So we know that this 0.5 can simply be written as what? 1 all over 2. So we can transform this now to be 8 raised to the power of x equals to 1 all over 2. And this 1 all over 2 can be transformed to 2 to the power of minus 1. So it means 1 all over 2 now can be transformed to this. So we now have 8 to the power of x equals to 2 raised to the power of minus 1. So you try to make the base the same. Raise 2 to the power of what number will give us 8? So it means we have 2 raised to the power of 3. So 2 times 2 times 2, 3 times will give us 8. So 2 raised to the power of 3 will be equals to 2 raised to the power of minus 1. As the base is the same, then you equate the power. Then we have 3x equals to minus 1. And we are looking for x. What will happen now is divide both sides by 3. 3 will cancel 3, we left with s, and it will be equals to 1 all over minus 1 all over 3. And that's it. Stand as result. Then the number 3, 9 raised to the power of 2x minus 1 equals to 8 raised as in 81 to the power of x minus 2 all over 3 raised to the power of x. So in this case, when you observe this particular expression, the smallest base here is 3, the denominator of this very one, the right hand side. So you would not think the possible way you are to make all of them now the same base. So you think of, you are raising 3 to the power of what to give you 9. Also you raise 3 to the power of what will give you 81. So in this case now, to raise 3 to the power of 2 will give us 9. And this can be transformed to this. That is the left hand side now. Then to equal to this 81 that is at the right hand side, it means 3 raised to the power of 4 will give you 81. So this can be transformed to this. All over 3 raised to the power of x. Now since the base is all the same, then in this case, we cannot, the left hand side now will be right as this, and the right hand side, according to the law of indices, if you are dividing, then you what? You minus the power. So this can be transformed to be as, I mean to the right hand side now where I'm touching it. So the 3 now, instead of writing 3 raised to the power of 4, open bracket s minus 2, close all over these 3 now can be transformed to 3. Since the base is the same, you just write, then you what? You minus the power. So it will now be equals to 3 raised to the power of 4, open bracket x minus 2, close bracket minus x. So since the base is the same, then you equate the power. Will give us this 4x plus 2 equals to 4x minus 8 minus x. So in this place now you rearrange and collect the lifetime. So in this case 4x now minus x will give us 3x, and with your minus what? 8. So when you collect the lifetime, the 3, you take the 3 from the left hand side now as the 3x from the left hand side to the right. Then we have this. Then taking these 2 now to this, we turn to minus 2. So we have x equals to what? The minus 10 stand to be the result to that particular word simplification. So with these particular examples that we have done already, I believe we understand that by now. So once a similar case is given like that, you can't handle it. That is good. So is there any question regarding to this under the indices? If there is, then you can't box your questions. I will attempt to you. So at this point now, we continued as well the theory of logarithm. We know logarithm and indices, they are working hand in hand. So we're still going to have that idea of the law of indices, we apply it to this logarithm. Now, to this logarithm, if the log n to the base a equals to x, this can be transformed to n now equals to a raised to the power of x. It means the base here now you raise the base to the power of the equal signs of what we as in what you have at the right hand side, you raise it to the power of that. So it means your n now will be equals to a raised to the power of x. We have it as this. Now, take for instance, if a question is given as this, evaluate log 25 to base 5. So you can press calculator, but the calculator does not have what? The base 5. All the base set in the calculator now is to the base 10. So we don't have exact of what? The base 5. So for you now to simplify this, you cannot equate or you equal that to what? To whatever the alphabet you feel like. If you wish, you use the alphabet that stands for your name. So in this my own here now, I'm now using the log 25 to base 5 now equals to x. So in this frame now, we transform this to the nature of this particular the general term we demonstrated. Then we have the 25 equals to 5 raised to the power of x. So at this point, the idea of the law of indices now will come in. You trying to what? To make this 25 to have the firm base with the 5 that raised to the power of x at the right hand side. So that if the base is the same now, you already equate the power. So you think of that. So 5 now will raise to what power will give me 25? It will raise to the power of 2. Then it will now be written as 5 raised to the power of 2 equals to 5 raised to the power of what? X. As the base is the same, then we equate the power. Implies that x equals to 2. I believe you understand. Now, see this similar example again, that if you are to evaluate log 8 to the base 2, and you can let it to be as this, the log 8 to the base 2 equals to y. At this point, you can transform the number to 8 equals to 2 raised to the power of y. Since these 2 raised to the power of y and the 2 is the base, so think of this very 8. You raise 2 to what power will give you that 8? So 2 raised to the power of 3 will give you 8. As the base is the same, you also equate what? The power. Nouns. Let's go further. Law of logarithm. So as the indices have their own laws, we also have the words, the law of logarithm. 1. Log x, y. It means x and y joined together to base a. So we can transform this now to be equals to log x to base a plus log y to base a. It means when you are multiplying the log of certain number to a certain base, then we can transform it to be odd. As we are multiplying, it will be odd. We add it with the separate variables assigned. So the above none is referred to as the first law of the logarithm. Now, example under that. Take for instance, and I will now say log 25 to base 10 plus log 40 to base 10. In this case, is now given in what? In the separate log. So as is given in this addition, we can also transform it to be in form of what? The multiplication. So we can rewrite this one to this. Saying the same base, you pick one of the base, that is the log 10 to the base 10, as the logarithm of base 10 into this 25 times the 40. So 25 times 40 now will give us 1000, meaning we have the log 1000 to base 10. So the log of 1000 to base 10, we can equate it to what? An alphabet y. So in this form, we can transform this to this. So 1000 equals to 10 raised to the power of y. So in this point now, since the base is 10, trying to make the 1000 to be in form of 10 raised to the power of what? The result will be what? 1000. So here now we have 10 raised to the power of 3. The result will be 1000. Then that will be equals to 10 raised to the power of y. As the base is the same, now you pay the power, implies that y equals to what? 3. Now, let's consider this, the second law. Log x to base a minus log y to base a. As they are minusing, then you what? You divide them. So it implies saying the log to the base is the same, base a. So you can write now as the log a and the log x all over y to base a. It means as they are minusing, you divide. So let's take for instance, evaluate log 100 to base 5 minus log 4 to base 5. So we have the result now as this. As they are minusing, you what? Transform it to be in form of what? Division. You can have it as log 100 divided by this 4 to the base 5. So 100 divided by 4 will give us 25. We have that as the log 25 to base 5. And we can equate this to whatever alphabet. Take for instance, now we equate it to t. Log 25 to base 5 now equals to t. Then this can be transformed to this. Remember the law of indices. So we also go into this very place with us the law there. So now, as we transform into this place, as it is, 25 now equals to 5 raised to the power of t. Then you make the base now the same, so that 5 raised to the power of 1 will give you 25. So here now 5 raised to the power of 2 will give you 25. So it means we write 5 raised to the power of 2 equals to 5 raised to the power of t. The base is the same, equate the power, implies t now equals to what? 2. So I believe we understand that. Now we also have another load, consider it to be this. Log x raised to the power of n to base a. This can be transformed to n log x to base a. So the above now refer to the third law of the logarithm. Take for instance, if example is given, you are to evaluate log a to base 2. So this can be transformed to this, the log 2 to the power of 3 base 2. Meaning, this very 8 now, you are to make the base the same to this. As in, you're going to make the log to the same base so that the log of the same base is equal to what? 1. Meaning the log 2 to base 2 is 1. Log 10 to base 10 is 1. And that applies to others number of the same log to the base. So in this case now, we now transform these 8 as the log 2 to the power of 3. It means if I raise 2 to the power of 3, I will have my 8. So in this case, we cannot carry the power of these 3 to the front. Then we now have it as 3 log 2 to base 2. So the log of 2 to base 2 is 1. So 1 times 3 now will give us what? 3. We have our result as this. Also, to these very ones, if we are to evaluate log 1000 to base 10, so we can also make this 1000 now to be of the log of the same base, meaning we say log 10 to what power? That will give us 1000 and to the base 10. So we can transform it to be as log 10 to the power of 3 to base 10. So the trainer can come down to the front. Now we have it to be as 3 log 10 to base 10. So the log of the same base is 1. 1 times this 3 is still 3. So I believe we understand the logic. So that is good. So we also have another in this form. Says log 4 to base 2 plus log n to base 2 minus log 14 to base 2. So they possess the same base, and that equals to 1. So in this case, remember when you are plotting this, the logarithm of a certain number plus another logarithm of a certain number, we can multiply that, transform it to multiplication. And when you are minusing, it can divide. So this very, the left hand side now can be transformed to the log of 4 to base 2 plus the log of n to base 2 can be transformed to be the log of 4 times the n to the base 2. Then divided, it means the result of this one, and minusing this, it means this one will divide this as we transform. So it will be divided what? The log 14 to base 2. So since they possess the same base now, it can transform to be the log to the base 2. Then 4 times n all over 14. And that will be equal to what? 1. So 4 times n will give us 4n. So log 4n all over 14 to base 2 equal to 1. So in this case, we can now transform this as we do it in what? In the law of indices. I mean the law of logarithm that define like this very one, log 8 to base 2. And you are to simplify that, we can equate it to any word alphabet, and we raise the base to the power of that alphabet, and that equals to the word, the 8. So that's exactly what will happen to this place. So this base 2 will now say it's 4n all over 14 now will be equal to 2 raised to the power of 1. We have it as this. So 2 raised to the power of 1 is 2. So 4n all over 14 equals to 2. Then we cross multiply, we have 4n equals to 2 times 14. That will give us 4n equals to 28. Divide both sides by 4, then n equals to 2. We have this. I believe we understand that now. Now, have this as an exercise. Go and play with it. Use the idea of the law and the principle involved on the previous example we did now to get your result. Simplifying the following. 1. 4 raised to the power of x equals to 1 all over 2. 2. 2 raised to the power of x times 2 raised to the power of 3x minus 1 equals to 1. 3. 3 raised to the power of 3 y 3y minus 6 equals to 24. Next, number 4. 5 raised to the power of 2x plus 4 equals to 1. 5, 9, open and close, 3 raised to the power of 2y close equals to 10, open and close, 3 raised to the power of y minus 1. Also, we have number 6, log 18 to base a plus log 8 to base 2 minus log 9 to base 2. At this point, I believe we understand how we can handle the one we have done. So now we go for that. We talk of the complex number. So a complex number is a mathematical expression that is a mixture of real numbers and imaginary numbers. This can be expressed in 3 forms, namely A. Algebra form, open and close, that is in standard. B. In polar form, and C. In exponential form. So we take them one after the other. Starting with the A, algebra form. So a complex number can be represented in the form of algebra expression as z equals to a plus bi, where a is the real part denoted by r, that is real z, that is, we'll now write it to be what? Re stand to be what? Real of the z, the complex number now. Then b is the imaginary part denoted as imaginary z, that is in, stand to be imaginary of the z. So the re, that is real, open and close, a plus bi close equals to what? A. Then the imaginary part now is in, open and close, a plus bi close equals to what? B. And the symbol I was obtained from the quadratic equations. 6x to the power of 2 plus 1 equals to 0. So if you are to simplify for x now, we have it as this. The result now will be square root of minus 1. That is x to the power of 2 plus 1 equals to 0. Taking our 1 to the right hand side, we have x to the power of 2 minus as it equals to minus 1. And we are looking for x, then we take the square root of both sides. Then we have x equals to the square root of minus 1. So the symbols I NAND was denoted to this the square root of minus 1, which is the complex power of the symbol I. Now, let's consider the positive integer. If I raised to the power of 1, it means the raised to the power of 1 is that thing, and our I now is what? The square root of minus 1. Now, if it is I raised to the power of 2, meaning the square root of minus 1 times the square root of minus 1. And if the root of a certain number multiplying it, the result is what? Is what is inside the root. It means the square root of minus 1 times the square root of minus 1, and it will be what? Minus 1. So meaning I squared is equals to what? Minus 1. Then I raised to the power of 3. This implies your I raised to the power of 2, open and close now to multiply another I. And the result of I raised to the power of minus, as the I raised to the power of 2 now is what? Is minus 1. And minus 1 times I, the result will be minus I. Is that clear? Now, if it is I raised to the power of 4, this can be the same as what? I raised to the power of 2, open and close square. It means, remember one of the law of indices, the law of x raised to the power of n, open and close n, with m now multiplying n. And here now the 2 now multiplying the 2 will give us what? The I raised to the power of 4 now. So we know that I raised to the power of 2 is equals to minus 1. And when we open and close that minus 1 to the power of 2, it will give us what? 1. So you would continue having them like that. Now, on these complex numbers, let's go by the operation in the complex number. Addition and subtraction. To add or subtract two or more complex number, we add or subtract the corresponding real and imaginary from each of the words, the complex number given. Take for instance, if 4 plus 5i, open and close, plus 2 minus 3i, open and close. So as we are adding, then we take the corresponding of what? The real uniting with the real, and the imaginary go with what? The imaginary. So we cannot have it to be as 4 is going to plus 2 and plus 5i is going to plus the minus 3i. So then we have our result as this. So 2 plus, as in 4 plus 2 will give us 6. Then 5 minus 3 will give us minus what? Give us 2. So we have our result now to be 6 plus 2i. So the addition, the imaginary, we go with the imaginary, the real, we go with the real. So, and that same also go towards the subtraction. So in the subtraction, the real will go with the real, then the words, the imaginary will go with the imaginary. So, and when you do so, we also have same. So like this very example now, that you should perform the following operation on the given complex number. A, 26 minus 7i, open and close, plus, open 1 minus 2i, close. So as they are odds, here now is what is plusing, while this second one is minusing. So it's the same. The real, we go with the real, you plus. The imaginary, we go with the imaginary, you plus. Here also the minus. The imaginary, we go with the imaginary, you minus. The real, we go with the real, you minus. And that gives you the result. So multiplication and subtraction are working hand in hand, taking the corresponding real with the real, imaginary with the what? Imaginary. Now, multiplication of complex number. The operation here is just the same as we will determine the products in multiplication. So take for instance 3 minus 4i, open and close, and is multiplying 2 plus I. So in this case now you will just what? Expand. So when you open the bracket by expansion, then we have our result as this. Or you can rearrange going by these three, the real part, multiplying the whole of this 2 plus I, and the minus 4i, we also multiplying this. So when you open the brackets here now, 3 times 2 will give us 6. 3 times 5 will give us 15i. Then here now 4i times 2 will give us 8i, and 4i times 5i. 5 as a 4 times 5 will give us 20. I times I will give us I squared. So in this point, 15i plus 8i, we possess the same ii. So you plus them together. So that gives us this plus this now will give us what? The 23i. So that we know that this I squared is the same as what? Minus 1 from the beginning. So in this case, where does I square, you replace it with 1. And 1 now times this 20 now will give us minus what? 20. So 6 minus 20, that is the real number, plus the 23i. At the end now, we have our result to be 23i now minus what? 14. To stand at this. So the multiplication of the complex numbers, then you what? You expand. Take the real, unite with the real, and imaginary unite with the imaginary, and you considering the words, the I. If it is I raised power of 2, then you replace it to be what? 1, as we have it earlier. If it is I raised power of 3, is giving us what? As we have earlier, should be what? Minus I. So it goes like that. Now, conjugate. Given a complex number a minus bi such that the product of these pairs is always entirely real. Examples. Show that the conjugate of the complex number a plus bi is a minus bi. So solution, by the definition for a minus bi to be the conjugate of a plus bi, their products must be entirely real. It means you take the product of them, then you expand. At the end of the day, the result is going to be what? Real. So if it is real, it means the a plus bi is a conjugate of a minus bi. So as you can see here now, when you take the product of it now, it gives us this. Is entirely what? Real. So that shows that it is a conjugate. So it means a plus bi is a conjugate of a minus bi. Then we can see this example also, that we should show that the complex number 7 minus 6i has a conjugate. 4 plus 3i. So to show that is a conjugate, then you what? You take the product of them. That is, you multiply. So 7 minus 6i now, open and close, you multiply it by 4 plus 3i. So when you expand this, then the result now is giving us to be what? 46 now minus 3i, as you can see. Meaning here now, 7 will multiply this. And also now minus 6i now will also multiplying this. So when you expand, 7 times 4 gives us 28. 7 times 3 gives us 21. Then minus 6i times 4 will give us 24i. Then minus 6i times 3i will give us the minus 18i squared. But our I squared that is already minus 1 earlier. So you substitute into that position. So it will give us the minus 1 times the minus 18. Automatically the result will be what? Plus. So from here now we have 28 plus 18 minus 3, because 21 minus 24 will give us minus 3, and with our I. So the resultant is not real here, as you can see. So that shows that the complex number 7 minus 6i is not a conjugate of 4 plus 3i. Because according to the rules, once they are conjugate of each other, then their product must be what? Entirely real. So this one is still giving us a complex form. So it's not a conjugate. Division of complex number. So to divide a complex number by a complex number, we multiply both the numerator and the denominator by the conjugate of the denominator. Meaning the conjugate now are said to be what? Take for instance, if I now say a plus bi, the conjugate of a plus bi now is a minus bi. So the sign now change will make them now to become a what? A conjugate of each other. If it is plus, the conjugate of it now will be minus. If it is minus, the conjugate of it is what? Will be plus. Now, examples. Simplifying the following complex number. 7 minus 4i divided by 4 plus 3i. Then, with this now 7 minus 4i divided by 4 plus 3i. So we can multiply it, both numerator and denominator, by the conjugate of the denominator. So the conjugate of this denominator, 4 plus 3i, would be what? 4 minus 3i. So you multiply both numerator and the denominator by that. So we have it as this. So at this point, so you have the idea of what the multiplication of the complex number. So you expand this by multiplying themselves. At the end of the day, now we have our result to be as this. 28 minus 21i minus 16i plus 12i squared. That is numerator. So when you expand the denominator, we have 16 minus 12i plus 12i minus 9i squared. To the one with the same I, you can marry them together to become one. We have this numerator as this. So also denominator now we have it as this. But our I squared is minus 1. So when you substitute words, you see the word I squared. So you replace that with minus 1, then we have our results as like this one. And the minus 1 times 12 will give us minus 12. So our numerator now will have 28 minus 12 minus the 37i, all divided by 16 plus 9, because here is minus 9i squared. Our I squared and is minus 1. Minus 1 times minus 9 will give us positive 9. So we have our result as this. So when you simplify it, we have 16 minus 37i all over the 25. So we can separate the real and all the imaginary. 16 divided by 25 minus 37i divided by 25. Then we have our result as this. That is, when you are dividing the complex number by a complex number, multiply both the numerator and numerator by what? The conjugate of the denominator. So we can do for the remaining example following the same procedure and continue. So here are the exercise. You can text this. Simplifying the following complex number: 2 all over 3 minus I. Then the big part of it, we have 3 minus I all over 4 minus 3i. C, we have 2 minus 5i all over open bracket 2 minus I close bracket open bracket 1 minus 3i close bracket. So you use that same ideology to continue with that. Now, square root of complex number. To find the square root of complex number, we equate the complex number to its original form, that is a plus bi, and solve. Now, example, find the square root of the complex number 15 plus 8i. So it means you take the square root of 15 plus 8i, equate it to what? The original form, which is a plus bi. So to simplify this, you take the square root of both sides. When you take the square root of both sides, then our left hand side now will become 15 plus 8i equal to, then a plus b, I open and close, now you square it. So at this point, 15 plus 8i equals to, as this one is squared, now you what? Is multiplying himself 2 times. So you open this by expansion. So when you expand this, we now have our result now to be as a squared plus 2a bi minus b squared, and as a b square I squared. But our I squared then is equals to what? Minus 1. So minus 1, and you replace it at the position of what? The I squared. Then the I squared now coming to what? As the minus 1 and represent this I squared, the minus 1 times this plus b squared. The result now will be minus b squared. So we have this. That is the simplification of what? The right hand side. Then at this point, you equate it. So our 15 plus 8i will be equal to the result. So at this very point now, you equate them by the real part we equal to the real part, meaning the a minus the a squared and minus b squared will be equal to 15, and this imaginary one now will be equal to what? The imaginary 8i from this point. Then you will now say from equation 2, you make A the subject. So we have now to B, as we are looking for A here now, you now say it, A now equals to 8 all over 2B. So 2 into 2 will give us 1. And 2 into 4, and 8 now will give us 4. Then our A now will be equals to 4 all over B. So at this point, you will now substitute the result of A into equation 1. Then when we substitute in, we have, that is our equation 1, and is giving us to be A squared minus B squared equals to 15. So our A now is already giving us to be what? 4 all over B. When we replace it, then we have 4 all over B all squared minus B squared equals to 15. So when you take the square root of 4 and square root of B, we now have to be the 16 all over B squared minus B squared equals to 15. So the left hand side now, you take the what? The LCM of it. So the LCM of B squared and 1 to be equals to B squared. B squared divided by B squared is 1. 1 times 16 gives us 16. So B squared now divided by 1 gives us B squared. B squared times the B squared now it gives us what? B to the power of 4. And that will be equals to what? 15. So you cross multiply, we now have 16 minus B raised to the power of 4 equals to 15B raised to the power of 2. Now you would rearrange by taking the B to the what? To the right hand side. This B raised to the power of 4, take it to the right hand side so that the family of B will be at the what? The same side. So we now have it to be B raised to the power of 4 plus 15B raised to the power of 2 equals to 16. So in this point now, we are looking for what? We are looking for the B and A. So at this very point now, we now have it to be 4 as in B raised to the power of 4 plus 16 raised to the power of 2. And that will be equals to 16. That is, we transform this 16 now to the left hand side, equate it to 0. So this will give us as the nature of what? The quadratic. So you will now factorize this B raised to the power of 4 plus 15 B raised to the power of 2 minus 16 equals to 0. So at the end of the day now we have our result to be as this. Plus or minus, open bracket 1 plus 4i, close brackets. So it's in polar form of complex number. So just like a real number can be represented on the Cartesian coordinate system by a point in a plane, a complex number can be as well be represented on the Cartesian coordinate system. So the idea was devised by a French mathematician, James Robert Argand, by plotting the pairs of real numbers a, b of the complex number, giving z equals to a plus bi as the point in the plane. Then join the point to the origin with a straight line. As you can see here now, this gives us the words, the sketch. So this is the vertical line, this is the horizontal line. Then this very straight line drawn out account the word, the horizontal. So coming to this place is B, here now is the R, stand to be the words, the complex form, where this place is A. So at the point where they meet here now is what? A comma B. So the straight line here is the complex number, which is what? Z. So the plane is called the complex plane. And the entire diagram is called the what? The Gantt diagram. So from that, let OP to be the complex number. Let R be the length of the Z, and let the T be the angle of Z. So make with the what? OX. Then by the Pythagorean theories now we have this. R squared equals to A plus, as the A raised power of 2 plus B raised power of 2. This implies when you take the square root of both sides, now we have R equals to the square root of A raised power of 2 plus B raised power of 2. And the tan theta equals to B all over A. And then the theta now we apply the tan inverse of what? B all over A. Also, we can write it as A equals to R cos theta and B equals to R sine theta. Since A, that's Z equals to A plus BI. So this implies that Z now equals to R cos this plus I R sine this. And that will be equals to R open bracket cos theta plus I sine theta. The factor R out because it's the same. So therefore, we now have this to be as this, and this one is called the polar form of the complex number. That is the Z equals to R open bracket cos theta plus I sine theta close bracket is now called the polar form of the complex number, while the R is called the modulus of the complex number Z, abbreviated as this. So you can see, or you can write it as what? The modulo of Z. Now, if Z equals to 2 plus 5i, then the modulo of Z now is equals to the square root of 2 squared plus 5 squared. So the 2 squared is 4, the 5 squared is 25, 25 plus 4 will give us 29, it's root, and that will give us that. Then 2, the theta now is called the argument of the complex number Z, abbreviated as this. So you can see, so those, if Z is equals to minus 3 plus as a minus 4i, then our argument Z will be equal to the tan inverse minus 4 all over 5. So the tan inverse now, when you open the bracket, give us 4 all over this, and the result now is 1.33. So when you take the tan inverse of 1.33, we have this, and this we have this. At the end, now this plus this now will give us this result. Are we clear now? So we stop at this.